here's the basic situation for this problem. We did a lot of it during class last time I saw you. There's a water flea. Now when fish are present in the water, they release this thing called pheromones, which they think that the water flea grows a longer tail, which makes it difficult for them to be eaten by the fish. So basically the pheromones alert them that the fish are around and they grow this long tail. Anyway, that's the idea. Now, what they did is they take a look at, what is it that they look at? Oh, the average length of the tail in these two groups. One had 214 in the group, and the average tail length was there. Now that's when the pheromones are present. And then another group had a shorter tail, and that's when the pheromones are absent. Now, is this a big enough difference to indicate that yes, the pheromones definitely have an effect on whether the tail grows or not? That's what we're trying to find out. Okay, so how are we going to do that? So I basically did the state part. Now let's take a look at our two hypotheses. So the null hypothesis is that let's see, there's no difference, right? So the average length of the population where there are pheromones present minus the average length when there are not present are going to be 0. But if there is a difference in this situation, the group that had the pheromones present would be longer. So if we subtracted them, sometimes I get confused as to what these things are, right? If we subtract them, what are we looking for? So you really have to kind of think about it. Well, yes, we would get a number that is bigger than 0. So those are our two hypotheses. If we subtract the two populations, we get 0, they're the same, versus a number bigger than 0, meaning there's definitely a difference. So there we go. That's the state. And then, and of course, let's not forget that we're going to use the alpha level of 0.05. Now, let's see. The plan is we're going to do a 2-sample t-test, but you know what? They took care of all that other stuff, random, normal, independent, for us. Okay, so let's go to the do part. So let's get started. We're going to do our t-value, or kind of like a z-score, or a test statistic. They're all kind of the same. But anyway, what we're going to do is we're going to subtract the two samples that we came up with, okay, versus what our null hypothesis says. Okay, that's how we do this thing. So remember, this is what we came up with our data, okay, when pheromones are present minus when they're not present, okay, we took that difference, versus what the null hypothesis says is that there's no difference. Now we need the new standard deviation. Okay, divided by the new standard deviation. That's this guy right here. Take the old standard deviation, square it, divided by how many was in that sample, okay? And then that other group, take that standard deviation, square it, divided by how many was in that sample, okay? So two separate ones, like we've done before. Add them together, take the square root, bada bing, bada boom, done. Okay, let's see what that number is. So the number we get is 14. So we're like 14 standard deviations out, when really our maximum is about 3. So this is huge, huge. So we're going to get a very small p-value. So we might get something a little bit different on the calculator, but basically it's like this. 2 times 10 to the negative 36. So that's basically 0.00000, 35 zeros in front of this 2. Super, super small, basically 0. So, okay, we have like no chance. Okay, I'm going to say this one more time. There's basically no chance of our data that we came up with actually happening if it's true that there's no change when there's pheromones present. Okay, so we can say that we're pretty sure that the pheromones in the water definitely have an effect. Oh, do we say definitely? Never in stats. Okay, hold on a second. we would say something like, we have strong evidence that we would reject the null hypothesis in favor of the alternative hypothesis, and that, having said that, pheromones in the water are having an effect on the tail lengths of these water fleas. There you go. Okay, so letter B says, what kinds of things will we need to know to ensure the integrity, I guess, of this experiment? Well, you know what? The sample size is pretty big, okay? All we need is sample size that's over 30 to indicate that it's normal, so that's pretty good. But there is an issue with the randomness, and that can be a real issue with conducting these experiments. How do you randomize? Where did they get these samples of fleas from? Were they from all over the lake? Did they take them from a certain place? Did they take them at night? Did they take them during the day? All kinds of things. So to ensure that the samples are truly random, that's some information that would be very important for this experiment. Okay, so that's kind of the answer to letter B. All right, let's go to the next one. Actually, I'm going to make a separate video for number 10. So, there you go. Like and subscribe. Bye.